y'all, so we're going to analyze some spicy irrationals. How we do this is with an acronym. Let me just write that down for you. It's BOBO, so BOBO. Who came up with this? I have no idea. And then we have BOTNO, or BOTN. Let's write BOTNO, why not? And then we have EATS DC. So BOBO means if the exponent is bigger on the bottom, then you have a zero asymptote. So it's going to be x equals 0, or sorry, y equals 0. BOTNO, this is going to be, if it's bigger on top, you're going to have no horizontal asymptote. No horizontal asymptote. If it's the exponents are the same, then you divide the coefficients. So that's how you find it for the horizontal asymptote. The vertical asymptote, you need to set denominator equal to 0. So let me show you how to do this real quick. So first, let's go ahead and do the horizontal asymptote. So what you need to do is take a look at the exponents, or the degrees of the top and the bottom. The degree of the top is 1. The degree of the bottom is 2. So this is a BOBO. It's bigger on the bottom. So that means you're going to have a horizontal asymptote at y equals 0. Because remember, bigger on the bottom means 0. So now let's go ahead and find the vertical asymptotes. So what you're going to do is you're just going to set the denominator equal to 0. And y'all know how to solve these. It's just a quadratic, so let's factor it as such. And you set each factor equal to 0, so you get x equals 2 and x equals -1. And these are the equations that are our vertical asymptote. So we have one at x equals 2 and another one that's at x equals -1. So these are the asymptotes. We don't know what holes yet are, and I'll show you an example with that maybe. So the domain and range, it's just going to be all real numbers but these. So for the domain, it's going to be x is the element of the reals, but x is not equal to 2 or -1. And the same with the range, y is an element of the reals, and y is not equal to 0. So this right here would be your answer. All right, we don't have any holes. All right, so let's go to the next example really quick. And here this is, so this one definitely is spicier, right? It just says identify all asymptotes and holes, so let's go ahead and do that. Let's go ahead and, before we even do anything, you know what, let's go ahead and just factor everything first. Why don't I take my own advice and factor everything first? So let's go ahead and do that. So let's factor the top. You get 2 times x cubed minus 8, and let's go ahead and group the bottom. Let's do the first grouping step. So let's take out an x squared. We're left with x minus 2 on the inside, and then a -9. We're left with x minus 2. So let's keep going, factoring both at the same time. So I want to do difference of cubes at the top. So we're going to have 2 times x minus 2 times x squared plus 2x plus 4. If you forgot how to do difference of cubes, remember it's SOAP for the signs, and there's a pattern. A minus b, a squared, a times b, and then b squared. So SOAP is for the signs. Now let's do this grouping step right here, and actually I'm going to have x squared minus 9, and then times x minus 2. So let's go ahead and just factor this again one more time. So let's write the top, x minus 2 up here, and then x squared plus 2x plus 4, and then over x minus 3 times x plus 3 times x minus 2. All right, so what we want to do here is go ahead and identify the horizontal asymptote. So what we can do is we can actually just look at the original equation because it's kind of easier to see maybe. And that's fine, we still have the original equation written down. So take a look at the top, it's 3, the degree is 3. The bottom, the degree is 3. So we have an EATS DC, the exponents are the same. So you're going to divide the leading coefficients. So we have a 2 in front of the x cubed, and then a 1 in front of the x cubed at the bottom. So we're going to have a horizontal asymptote. The HA is going to be y is equal to 2. All right, so now let's go ahead and search for all of the vertical asymptotes. So let's see. If we look at our factored expression here, you can see that the x minus 2 and the x minus 2, those are actually gonna cancel out, right? So let's go ahead and do that. So we have 2 times x squared plus 2x plus 4, and then over x minus 3 and then x plus 3. So our vertical asymptotes are actually what's going to, you remember if you set the denominator equal to 0, that's going to be the vertical asymptotes. So actually we can just say that the vertical asymptotes are at 3 and negative 3. If you set the bottom equal to 0, that's what you get. And now this other thing, we have to find the asymptotes in wholes. And we actually do have a hole this time. And you're going to have a hole if you cross out a term like this. Like if you cross out a term that has an x with it. So we crossed out an x minus 2. That's where we're going to have a hole. That's the x coordinate of the hole. Now to find the y coordinate of the hole, what you're going to do is you're going to plug in this x value into your equation that's left to find out what the y value is. So if I do that, let's see, 2 times 2 squared plus 2 times 2 plus 4. And then this is going to be over 2 minus 3 times 2 plus 3. So let's figure out what this is real quick. So this is 4, 4, and 4, so that's 12. So we're going to have 24 at the top, and then divided by negative 1 times 5, so that's going to be negative 5. So the y value is going to be negative 24 over 5. And that is the whole of our function. So that's going to be it. Let's go ahead and go to the next one. All right, identify all asymptotes and wholes. So let's go ahead and do that. Let's go ahead and factor everything first. Why not? So the first one's actually a difference of squares. So let's go ahead and do that. Let's factor that. Let's have x squared minus 9 and then x squared plus 9. And then divided by, we can actually factor this as well. We'll have 2x, let's see, plus 1 and then x minus 3. So let's go ahead and factor this top again. We have x squared minus 9. That's a difference of squares. So we can have x minus 3 times x plus 3 times x squared plus 9 over 2x plus 1 and x minus 3. So as you can see, this x minus 3, they can cancel out. So you know whenever we ask you for the wholes that you're going to have a hole at x equals 3. So let's go ahead and identify all the asymptotes. Let's just start with the vertical asymptotes. So we take a look at the resulting function that resulting expression we have. We set the bottom equal to 0. You should get that we have a vertical asymptote at x is equal to negative 1/2. So for the horizontal asymptote, let's look at the original function. We have it bigger on top. So it's bigger on top. So we are going to have no horizontal asymptote. So there is none. And let's see, what else do we have here? Let's look for any holes. So like I mentioned before, we are going to have a hole at x equals 3. Now we have to find the y value. So what we're going to do is we're going to plug that in. So we're going to have 3 plus 3 and then 9 plus 9 over, let's see, 3 times 2 plus 1, that's going to be 7. So at the top here we have a huge number. We have 9 times 18 over 7. So that is going to be 9 times 18 is 81, 162 over 7. So that's going to be the y value of our hole. All right, so we have one more example. I know this is a long video. I'm talking like super fast too. This is crazy. So we have to identify all the asymptotes and holes. And let's go ahead and do that. So let's try to factor everything. And actually we can't. We can't really factor the top. The bottom only has one term. So this is already fully factored. So let's go ahead and find our vertical asymptote. So our vertical asymptote is going to be at x equals negative 1. If we set the bottom equal to 0, you solve for x, you get negative 1. So horizontal asymptote, let's see. So we have a x squared at the top and an x at the bottom. So we're not going to have any horizontal asymptotes. But this is actually a special case. If it's just 1 above, if the top is just 1 higher than the bottom, so in this case 2 is 1 greater than 1, or for example, if you had an x cubed and an x squared, we're actually going to have what's called a slant asymptote. So what you have to do is we have to do long division. So let's go ahead and do long division. which I know is everybody's favorite thing to do. So how many times is x going to x squared? X times, and then you multiply x squared plus 1 times x, so that's x. Subtract down, you get x minus 4. How many times is x going to x? 1 time, so you get x plus 1, and then you're going to have negative 5 left over. So what the slant asymptote is going to be is actually whatever is up here without the remainder. So we don't care about this that much. It's just what's up here. So we're actually going to have a slant asymptote at y is equal to x plus 1. And that's it. We don't have any holes since we didn't cancel anything out. And yeah, we just have a vertical asymptote and a slant asymptote. So that's going to be it for this video. I know it was kind of longer, but I did try to go as fast as I can. So thank you for watching, and I'll see you in the next one.